was actually at the notice.
Okay, we got more stuff. If you would have read the page, you might have it.
Yeah, I read most of this. We're learning this stuff about tomorrow's test. We're learning it two little slivers of stuff. One we already know, kind of, one we don't. And then we'll review a little bit. Some of you will feel all right. Some of you will feel panicked. Sorry, you're right. All right, so let's go ahead. Put these in. Hold on. Actually, the most Sorry. All right. So this might be a strange order to go about things, but today I want to make sure you understand what molarity really is. Yeah, it's probably loud. One thing I'm struggling with this year, I don't know that kids are really reading. You're leaning 110% on me to teach you everything, but I teach you about 70% of the stuff with what I think is a realistic expectation that you'll teach yourself the other 30. Anyway, now molarity, it's in the book. So are titrations. That's the other thing we're going to talk about today. But if you're looking in the book and you're like, oh, we never talked about that, that won't be on the test. You could not be more wrong. All right, molarity. We've been using molarity the entire week. It was in the videos. We've used it a lot. Molarity is simply a unit of concentration that is equal to moles solute over liters solution. All right. Now, the solute, you need to know this. That's generally the solid that dissolves or dissociates. It doesn't matter which word you want to use. And then the solvent, that's the liquid it dissolves in. And the solution is the combination of both of them. Okay, so molarity, we've used it. It's been super nice because it relates moles, and moles is the only way I can compare two things on the periodic table to each other. Okay, so it gives us a way. We go from grams of one thing and grams of another thing. We get them both to moles, and they can now both talk to each other. Okay, remember, moles was like our dollar. It was how we related everything else to each other. Because apples and oranges aren't the same, but money, which we would buy them with, it is always the same. All right, so there we go. We have molarity. It's moles of solution over liters of solution. And we've been using it when I've given you like a concentration of KNO3, and I said you had 200 milliliters of a 3 molar solution. I think all of you now are comfortable with how to find moles from this. We've taken advantage of the fact that molarity is not just a capital M, it's a moles per liter. So we were saying, all right, this is 0.2 liters. I have 3 moles for every 1 liter. So if I have this much, I have 0.6 moles of whichever thing I was talking about. Are we okay with that? We were taking advantage of this proportion of molarity. Are you okay with this? You tell me. Raise your hands if you're okay with this. Okay. Now, the one thing I have not done is asked you to do a problem that asked you to solve for molarity. Now, molarity, we just barely told you, is what unit over what unit? Moles over liter. To solve a problem for molarity, it always gives you grams and liters and asks you to find molarity. So what do you need to do to the grams? You convert them to moles. And then you divide by the liters. Doesn't sound very difficult, I hope. So let's do one. You have 80 grams of NaCl in 50 milliliters of water. We'll just call it solution. I don't want you to trip out. What's the molarity equal to? So spend a few seconds, minutes, well, no longer than 2 minutes, and figure out the molarity of this solution. Natasha. Yep. Will you pass this to David? David, pass this to Spencer. It's funny a kid in the engineering program has not even signed the computer use agreement yet. Okay. This won't surprise anyone, but I'm going to do this in a picket fence. I'm going to estimate that this is around 1.2. Okay, who has an answer? Raise your hands. Okay, what is the answer? Is it close to 1.2? Okay, 7 people raised their hands. One of you feel free to say a number. 2.7? Oh, I screwed up somewhere bad. Wow, where did my math in my head go so wrong? Okay. All right, 2.7 molarity. Who had that? Raise your hands. Okay. You do not have to do it in a picket fence. I did it this way because this is a proportion, and I'm used to molar mass being a proportion. But if you look, this sliver right here, all that is finding the moles, right? And then what's adding this on doing? That's dividing by the volume, and that's where your molarity can come in. Okay? So use your grams, divide them by the molar mass, and then divide it by your volume. Are we sort of all right with that? Okay, there is a question on the test like that. The final thing that we need to talk about that is not review is a titration. And I'm going to talk you through titration, and then we're going to do the math, and then we're going to teach you that it's very simple. All right, a titration takes advantage of a lot of things. It's going to take advantage of the fact that a neutral solution has a pH of 7. Now, we haven't really even talked about the pH scale, but just know that the pH scale goes from 1 to 14. If it's 1, it's a very strong, I shouldn't say that, it's a very concentrated acid. If it's a 14, it's a very concentrated base. And when I say concentrated, what ion am I talking about for an acid? H+. An acid has a ton of H+, and a base has a ton of OH-. Well, in between 1 and 14 is the number 7. And 7 is when the amount of H+ is equal to the amount of OH-. Okay? So we're going to take advantage of this fact, that at a pH 7, H+ is equal to OH-. Who's with me on that one so far? Okay. All right. The titration also takes advantage of what we call an indicator. An indicator changes color over a pH range. So, a typical indicator we could call is universal indicator. It's a liquid that I add to an acid or a base, and it changes color depending on the pH. Now, this will probably be hard to see, but it's like this. 1, 2, 3, 4. This will take forever. I don't know if it's worth it. This is supposed to be, I don't like that color. Let's start making it green. So this is like yellow, bright yellow, orangish. Then it starts to turn a little bit green. 5, 6, 7, 8. And then I'm just going to stop wasting time. 9, 10, 11, 12, 13, 14. Okay? So it's going to start yellow, kind of get a darkish orange yellow, then start to turn greenish, and then be the darkest green right at a pH of 7. Okay. So if I have something, I have it yellow, I can add base until the substance turns green. And what do I know when it turns green? I know that when this substance turns green, that the H+ and the OH- must be equal.
Is that actually what the universal indicator does? Like, is that actually the color? Or is it?
Yeah, it is.
Oh, okay. I thought you were just
I didn't, like, there's a few things in the middle, but it's plenty good enough. It really ends dark purple, but who cares? Yeah, go ahead.
What does pH stand for?
You don't, no one needs to know this, but since he asked, we'll learn it a lot later. pH stands for the negative log of the H+ concentration. It's not that bad. In chemistry, I think in every science, P, it means power, but it really means negative log. And if you're just math nerdy enough, negative log really means find the negative exponent that this number, the whatever, that should be a parenthesis, sorry, it's not concentration, whatever, is raised to. Okay? Kids have a heart attack when you use the term log. But log is just finding you have a number, all right, it equals an answer. You have the answer, you have this number, but you're trying to find the exponent it's raised to that gave you that answer. That's all a log is. So pH means find me the negative exponent that the concentration of hydronium was added or was raised to get that number. So if I have a pH equals 7, just stick with me. If pH equals 7, then the H plus concentration is 1 times 10 to the negative 7. There is your relationship. That's a 1. Okay? So it would say that my concentration of H plus is this concentration. Okay, and we will learn about this in a chapter called Chapter 16. All right, now I'm going to move to a new page. All right, so this is what we'll do. In a titration, once again, we have the following things. Here's a beaker, and it has some acid in it. Now, there's a problem. I know how much I have, but I don't know its concentration. So I know volume. I don't know concentration. I'm going to put an indicator in there. And since it's an acid, I know it's going to be like red, orange, yellow, something that's a warm color. Okay? Then, I'm going to use a tool called a burette. A burette is essentially, so I have my ring stand here. I have this clamp. All right, and it's going to connect to this thing called a burette. Oh, I tried to make it straight. And it's basically a graduated cylinder with a little valve at the bottom that I can open up and control the volume that I add. You okay with that? Any guesses what I'm going to put in the graduated cylinder, or the burette? I'm going to put a base. Now, I am going to know the concentration. Okay, now we'll see how this works. So just kind of, I don't know, you're writing stuff still. When you're all done, look at the screen for a second. I'm going to record the volume that I start at, and then I'm going to open this valve. And if I can grab the right part, nope, nope, I want the blue, nope, the blue, there we go. I'm going to open this valve, and the volume is going to start decreasing because I'm adding it here, right? And I'm going to keep adding until what happens? Until it turns green. Because when it turns green, what do I know? pH equals 7, which I actually know even more than that. If I know the pH equals 7, I know what? I know that those equal each other, correct? All right, so now I'm kind of off to the races. If I kept track of my volume, whoops, not concentration, if I kept track of my volume, it's now known. So stick with me right here. If H plus and OH minus equal each other at pH 7, that means that the moles of H plus equal the moles of OH minus at a pH of 7. Look right here. If I know the concentration of volume of something, then I actually know the what? I know the moles. Now look down here. The aha is coming. If I know the moles of base that I added, then what do I actually know also? The amount of H plus that I had to start with. They have to equal each other, do they not? That's the whole point of taking advantage of this pH of 7. So let's put some numbers in here. Let's say, did I already say the volume? Did you write it in your notes? What? Okay, maybe I didn't. So let's say it was 200 milliliters in this graduated cylinder, or this beaker. Okay, that's my known volume of acid. Now, I'm going to take this base, and let's say that I know that it's 3 molar concentration, and that I had to add 40 milliliters to get this to become neutral. So, based on 3 and 40, I can find the moles of my base right here. Because moles is equal to volume times concentration. So what was my volume of base I added? 40. And I'm going to start doing it in liters because I have to. Because molarity is in liters, right? So I had 0.4 liters. For every 1 liter, what was the molarity? It was 3 moles, right? So that's equal to 0.12, right? So now look, I'm going to come right up here in this space. I know it's a pain, probably. 0.12 moles has to equal this side, correct? Well, I don't know the moles, but I do know what? I had 0.2 liters times something is equal to 0.12. So how do I solve this algebra? I take 0.2 over, and I end up with 0.6, right? It's 0.6, right? So my initial concentration that I did not know was 0.6. Okay. Well, that was TOF. Tons of fun. Not tough. All right. Let's chop this up a little teeny bit. How do we find the moles of acid and base mathematically? It was volume times concentration, right? Was it not? And this is for my acid. And it has to be equal to volume times my concentration of base. Hold on. Why did I do that? All right? What is going on here? So this is my actual math behind this. Like, understanding the science is important, but doing the math is important too, and it's super easy. I take the volume acid times molarity acid, and it
They said in the textbook you can also use that equation when you're solving for just like final concentration of like when you dilute something.
Yep, this is the same exact math as dilution.
Okay, when can you not use it?
When you're not mixing an acid and a base.
Or when you're not doing that.
When you're not doing a dilution. Like, it's if you are given 3 numbers and asked for a fourth, it's almost like it's always this.
Okay.
And by the way, the reason why dilution works is because in a dilution, the moles stay constant. Yeah, you're just adding more solvent. But if the moles are always equal, then you can use the same idea as pH, meaning the moles were equal to solve. There's your titration, there's your dilution. There's a homework problem. Are you ready? It's in the back. It's number 70-something. Now, if you have the white book, we found out that they get off by 2. So if I assigned 87, it's 85. Is that what we decided, Spencer? Okay. Chapter 4, question number 73 in the black book says the following, and it might have been a pain in the butt if you already did it, when in the long run it's easy. It says you have a stock solution of 14.8 molar. Okay, so my concentration here is 14.8 molar, capital M. I continue to read. It says, how many milliliters of this solution? So there's what you're going to solve for. Milliliters of that solution. Okay. Should you use to dilute to make 1,000 milliliters of 0.25? Yada, 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 yada. So, I mean, the way I wrote it, it's pretty easy. What two numbers are connected by the word of? These two, so turn that into a multiply sign, and then you're going to divide by 14.8. Now, you're dealing with molarity, so this 1,000 milliliters should be what? 1 liter. And in the long run, that doesn't really matter, but in other areas it sure does, so just keep that pattern. Yep. Right. So when you solve this, is it 0.016? No, that's a different problem. What's the answer? You got 0.016? Okay, it is 0.016. But that's liters, so you have to do what one more time? 16 milliliters. Now, you would have gotten that if you didn't do the 1,000. We're just sticking by converting back to liters just because most of the time it matters a ton. Okay, in part B of that same problem, if you take 10.9 milliliters of the stock solution, so there we go, we have 10 milliliters of 14.8 molar, yada, 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 yada. How do you dilute it to 500 milliliters? Well, I am going to stick with tradition and convert this to 0.01 liters. Then I'm going to make of a multiply sign, and then I'm going to divide by 0.5 liters. And I don't remember that answer from last hour. What's that? Yep. And this unit would be molar. Those are not very hard. All right. I hope this doesn't take as long as first hour to open this thing, and then it shut itself down. That's always a great day. Come on. All right, this is the Chapter 4 exam from 2013. So it is not the version you will take. It wasn't the version they took last year either, but it's going to be super close. Now, when we got done with this, everyone was pretty excited that it didn't seem very hard. And it may or may not seem very hard, but do know there is also multiple choice problems. So let's look through these real quick. Do not take pictures. You can take some notes if you feel like it, but I'm going to go fairly fast. So it says acetone is used to clean fingernail polish off of fingernails. Which is the solute? Well, what is the solute? It's the thing being dissolved, right? So it would be the fingernail polish. Okay. Last hour claims that they had no idea how to answer this question. Which of the following would be considered a salt? A salt simply means a metal-nonmetal pair. I don't know how I did not say that a million times to them like I did to everyone I've ever taught. But look for a metal-nonmetal pair. It's an ionic compound. Number 4, a reaction in which an element loses an electron and an element gains an electron is called a what type of reaction? It's redox. And in redox, make sure you know who loses and who gains. If you remember, Leo the Lion says grr, you can answer most of that question. Number 5, how many milliliters of this are needed to be diluted to make that of that? So what's this problem? Okay, it's those times each other, then divide by 6. Number 6, kids don't like because you have to use words. You have to write. Use the words solute, solvent, solution, and electrolyte to describe a mixture of salt water. If you don't know, then read it again. Look in your notes. We covered electrolytes a lot. Then, even though you would never do it, why would it be theoretically safe to drink a mixture of isomolar hydrochloric acid and sodium hydroxide? What does iso mean in science? Equal or the same. Okay? So like an isotope, it means the same type. An isotope, the same element, different numbers of neutrons. Isothermal means that the temperatures are the same or equal. Isomolar means I'm adding the same amount of moles of acid and base, which means it's what? There you go. What is the molarity of a solution? So you got to convert grams to moles and divide by volume. Number 9, I'm pretty rigid on the way I grade them. Balance and answer the questions relating to the reaction. Tons of kids will balance this and move on. It's worth 5 points each. If you balance it and move on, you get 2 out of the 5 points. The answer to the question is the third. If it has something like oxidation, then you need to write out the oxidation stuff. All right, then this is the exact problem we did yesterday in class, word for word. The only difference is it requires you to put your answers in a box. And if you don't put them in the box, I'm not going to grade them, because it took me longer for me to find your answers yesterday or last test than it did to grade almost the rest of your whole test. So you're going to write the you'll write what the thing is and then its concentration. Easy enough. I left those blanks because I want you to be able to break these up the right way. Okay, that doesn't seem that hard, right? Okay, this is tomorrow, and my expectation is that it will be done tomorrow. Oh, dang, I was hoping that the other part was there. The multiple choice will be given separately on Monday. Okay, I won't even hand it out because I know you won't get through both.
And is it basically the same stuff as?
Here, yeah. Let's look. Now, I reserve the right to change any of this I feel like changing. But I won't change a lot. I'll tell you that much right now. Most kids absolutely bomb this part of their test. Just FYI. And I look through it and I think, how? Like, it's not that bad. All right. A weak electrolyte exists predominantly as blank is solutions. What does a weak electrolyte mean as far as a solution is concerned? It doesn't dissociate. So look for the thing up there that said it did not dissociate. Then it asks, which of the following are weak electrolytes, which means they don't dissociate. All right? There's 2 acids up there. There's a base. And then there's something from family 1 and something from family 7. What do you know about family 1 and 7 when they're in solution? They are always soluble. Okay, next. This is giving you these and asking for the spectator ions. This is essentially the same, but this time it's asking for the net ionic. So it's everything but the spectator ions. Number 5, of the following elements, blank is the only one that cannot be found in nature in its elemental form. And that one might seem weird, like he's never talked about that. But that question has everything to do with what we call the activity series, which was when we had metals that were easily oxidized, and then they were ranked going down, with the bottom being the least easily oxidized. And if you remember, the things at the bottom were metals that were like jewelry was made out of, because they don't react. They are not oxidized. They don't rust. They don't do anything. But what elements do react with just about everything? Where do they live on the periodic table? Family 1. Okay? You don't have to have the activity series memorized for this test, but you dang well better have a pretty good idea that family 1 is at the top. Family 2 is below it. Then transition metals are below those. Then you have hydrogen. Then you have all of your jewelries.
So are we going to be given the activity series?
You are not.
We are not till we print it off.
And study it tonight all you want, but you cannot have the activity series on your test. You don't need it. I'm telling you, like, you need to have above average intelligence, which all of you do, and you need to have the idea that reactivity decreases as you move right, essentially. All right, then oxidation cannot occur without the other half. That one should be 100% of you. There's a couple questions like this, so make sure that you're okay with oxidation numbers. Which species does sulfur have the highest oxidation number? Oxidation numbers can be found by using who it's with. And like, I don't know, that was super duper simple in my opinion. Like, you can look at it and know. But you're not at my level, most of you, so don't think, man, I got to drop this class. Which of the following is an oxidation reduction reaction? This one takes some time, but is not super hard. It just takes a little bit of time. Oh, never mind. This one does not take time. It's the one that says, and it's probably on your real test, it says which one is not an oxidation reduction. That one takes time. Oxidation is the blank and reduction is the blank. That's just the definition. Yada, yada, yada. Only blank is not an electrolyte. That one's so dumb. Some kids will get it wrong. Strong acids, there's nothing to say except for memorize your strong acids, because one of these is not on there. I like these a lot. There's 2 of them, and they take thinking. Based on the equations below, which metal is the most active? Okay? All right? You can use those to figure out. Remember, activity series. The most active ones are at the top. The least active ones are at the bottom. Which of these metal is least easily oxidized? Get it wrong? Well, I guess actually there is. I'd say that's a difficulty of a 2 out of 5. But the summary of the table I just barely gave you will get you through that question very simply. You have to have your strong bases memorized. A neutralization reaction between an acid and a metal hydroxide produces something. Which one is the most easily oxidized on this list? Gosh dang. If you understand that section, that one's super, super, super easy. How many moles? We've done this 100 times. I give you a volume, a molarity, you find me moles. Super not hard. who thinks they already know that answer right now? Okay. The rest of you should really remind yourselves how to do that. Number 19 is the hardest question on the entire test. Which is the correct order of increasing activity for these metals? Now, it's hard because may or may not follow the activity series. So you have to use the data to figure out who can beat up who. Then this one's super easy. There are blank moles of bromide ions in that many of that many. I already have done it. Like, you can do these things. Okay, this will be on Monday, as well as something I don't know if we got to yesterday. Did I ask you how to identify 3 acids, given only that you know they are one of 3 acids? Okay, we better do that question. It's in your homework. But you have to do this, and you will do it on Monday. Man, I had it written yesterday, but it'll take me longer to find actually where it's at. So essentially, you have the following things. You have acid A, B, and C. And you don't know which is which, but you know one of them is HCl, one of them is HNO3, and one of them is H2SO4. And then you are given 2 things that I can't remember. It's Ca plus 2 ion. It's something else, but the anion won't matter. And Pb plus 2. You will have, so you'll have these 3 pipettes, these 2 pipettes, and based on chemistry, you have to tell me what each letter is. Think through how you would actually do this in the lab. You'll need your solubility rules. But I will tell you in the book, it doesn't say, in the printout I give you it does, but I will tell you that calcium does form a precipitate with SO4. I want you to talk through with your lab partner how you might figure out what those 3 acids are.
So, and then if it forms neither, yeah, nitrate is always soluble.
All right. I heard Christine say it the loudest. So Christine, I would like you to explain, because you did it right. How would you do this?
So, looking at your solubility rules, you know that if you add calcium to something and it forms a precipitate, the only acid it will form a precipitate with is sulfuric acid. So you know
Okay.
that if it forms a precipitate, that acid was sulfuric acid.
Okay.
And then if you look at your solubility rules again, the only one that will form a precipitate with is HCl. So
Okay, that's pretty close. There is one little thing. You'd be fine, but there is one little thing wrong. HCl makes one precipitate. SO4 makes two. It makes that and lead. And this makes none. So you're gonna have a spot plate that'll look like this. Based on that, what am I talking about? What is acid A? H2SO4, because there's two cloudy things. What's acid B? HCl, and then nitrate was the easiest one right there. Okay, you're going to do this in the lab on Monday. Okay, that is part of the test. All right. I really think I might change my mind here. We're going to test tomorrow, that's for sure. We're going to test Monday, that's for sure. I think Tuesday, Wednesday, Thursday, Friday, there's like 4 labs, and I'm going to assign you to do 2 of the 4 of them. I think we're going to have next week just be lab day, lab week, and just knock them out. Finish up, well, never mind, you did. First hour still never finished their lab from years ago because I forgot about it. So we might just spend the whole week in the lab. It depends on what kind of mood I'm in. All right. Please study. Please use the internet, right, June? There's lots of helps out there on that internet site.